Okay.
Make sure you guys put your name in the chat. Thank you.
It's right there. Okay. All right. Have your videos on. Please have your first and last name on the screen and on the chat. Please show it. Did they show you guys the phone?
Not yet.
Cell phone in places where you cannot access it during the lecture. Okay. So let me have you do that.
Yeah, I just did it right now.
Put that away. Thank you, Alexis. Sarah, what happened to Sarah? Sarah. Alex, do you have two?
Yeah,
Oh,
I have
two.
my
Okay.
iPad on here,
Okay, got it.
so I can share my screen later.
Oh, good. Yeah, that's on my computer I don't have cam on it. I only have iPad. So when I switch, application, it automatically turns off the cam. So unfortunately, I can't do that. I guess I gotta invest, on cam.
I think Alex was able to do it, but yeah, we'll figure that out later. Sorry. Go for it.
Okay. There is a lot of written information here. I'll probably erase it, some of you, but I'll keep it, right? All right. So here, I noticed that from previous lectures, this is my 4th lecture today, right? That all the groups haven't actually gone through module number 3. Right? So, Adrian, Patricia, Alexis, Sarah, have you guys gone through module number 3?
I went over it this morning, but
This morning?
I didn't get to the last part.
Okay. What about Andrew?
Yeah, I went through the Quizlet. They told us to sign up for the Quizlet. I went through the flashcards.
Nice.
Flashcards. Cassandra, did you go through module number 3?
Yeah, I went through the textbook and everything.
Okay. So you guys have an idea of what we're going to be doing, yes?
Yeah.
Somewhat.
Okay. Somewhat. Let's look at it. So let me give you an overview of what we're going to be doing right here. Okay. So here, there are 4 learning objectives that we're going to be looking at. How to create and interpret a histogram, right? Shape, center, and spread are the 3 components of the numerical distribution that we're going to be looking at. Those are the 3 key components. How to identify various shape of distribution, and then using shape, center, and spread to describe the symmetric distribution. Okay, so here, from module number 2, right, we looked at what we call the dot plot and stem plot from the previous module are examples of what we call the numerical data, okay? One other numerical data, examples of the numerical, how to organize your numerical data is histogram. We briefly saw that because we wanted to cover majority of that histogram portion in the module number 3, and which is actually the most important graphical representation of your numerical data, okay? So far, so good. But when you come across a large data set, right? Okay, dot plot and step plots are not sufficient enough. Okay, so we need another type of graph, right? That to organize your numerical data is the histogram and what we call the box plot. Okay, depending on the type of graph that we're looking at and the distribution, we will usually graph it histogram, or you will usually graph it in box plot. Okay, so far so good. If it's a skew distribution, then we're going to be looking at it as a box plot. If we're symmetrical distribution, then we're going to be looking at what we call the histogram or normal distribution. Okay, so far so good. Okay, again, histogram is a numerical data, right? Organization of the numerical data. Okay, histogram is very common graphing choice for numerical data. Histogram is not a bar graph, right? Bar graph what? Do not touch. Oh, histogram, right? Do not touch. Whereas histogram is what? They touch, right? Each other. Okay, that's the key difference, which also one of the major differences that bar graph deals with what we call categorical data. Histogram deals with numerical data. Okay, so far so good. Any question? Okay, histogram is a graph that divides up the numerical data into separate bins. We usually call bin in other books. They also make that as a same terminology. It's called classes. Okay. Okay. So far so good. Okay. So histogram is a graph that divides up the numerical data into separate bins and then counts the frequency of each bin. So we want to figure out the frequency. Okay, who here watched yesterday's lecture? Okay, so Patricia watched. Okay, any other?
I watched it.
Who's I? Sarah?
Cassandra.
Cassandra? Okay.
Sarah did too.
Right. So you should have watched the lecture, or if you haven't watched it, go back and watch the recording, because yesterday what we went over is how to organize your what we call the categorical data. Right. Categorical data is very, very easy to organize, because one way to organize it, because when I say about the bin is actually distincted here, okay? Because when we look at this categorical data that deals with Skittles here, okay, with the frequency, right? Normally, when you're actually collecting a data, what do? Right? So if we want to figure out what portion of your bag of Skittles contains red color, orange color, yellow color, green color, purple color, what do? You open a bag of Skittles, right? And then you go, okay, the first one came out to be red, orange, second one, third one, green, fourth one, purple, and so forth. This is what poor way of organizing your categorical data. Logically, what would you do? My kid will say, oh, my kid will go, I'm going to bring my 5 set of bowls, right? Okay. And then whatever, I'm going to divide up all the, red color, orange color, and green color and put it into that bowl. So you'll put it into here, which we call the red bin. Okay. Here, orange bowl, we call the orange bin, right? And then the yellow bin, green bin, and so forth. And then we will put it accordingly. And then once we actually put it into dump it into those bin, what do we need to do? Count the number of Skittles. And this is what they did. Okay, we got 23 reds, 44 oranges, 37 yellows, and so forth. Okay, but it's clearly defined in categorical variable. Okay, it's clearly defined. Red, so your purple will not go into red. Unless you're colorblind, it will not, right? Okay, so you will not dump into here, right? Okay, but the difference between what we call the bar graph and histogram, the histogram does not have a clear-cut what we call the bins, okay, or what we call numerical bins, okay? So when you look at something like this, a stem and leaf plot right here, stem and leaf plot organizes what we call the a numerical data in what we call the horizontal form, okay? The first one, so basically you have raw data, I don't know why that was erased it. So we have raw data from module number 2. Raw data, ages of people attending community college, right here. So therefore, we have 18-year-old, 18-year-old, 19-year-old, 20-year-old, 21-year-old, all the way to 49-year-old, right? So far, so good, right? So they identified what we call, if you split this, as you could see, this leftmost number represents the leaf, and then this represents the stem. Okay, stem and leaf, hence. Okay, so rightmost number is considered to be the leaf, and leftmost represents the stem in this case. And this number, what number is this right here? It's in what? Tens category, right? So therefore, this right here is, right, a bin. This is your bin, basically. Your tens, your 20s, your 30s, your 40s. Get the idea, right? So 18, 19, 20, 21, 21, and so forth. Okay. What's great about stem and leaf plot and dot plot is that you don't ever lose your raw data. Your raw data is right there sitting in here. I could figure out every single person's age right here. Okay. Unfortunately, stem and leaf plot and dot plot are not good for large set of data. If you have, say, thousands of data, it's going to be very cumbersome to graph something like this. It's going to take you a long time. Okay. So that's why we refer to what we call the histogram. Okay. So far, so good. Okay. One thing here, you yourself have to decide what bin width you want to work with. In numerical data, there is no clear-cut bin, right? There is no definitive bin like red bin, orange bin, like the color bins, right? Okay. You have to decide. Okay. So they give it to you here. So they made the bin width to be size 10 here, which means that this is the teens or tens, this is the 20s, this is the 30s, this is the 40s, right? Okay. But we come across a problem when you have something like 20. Where does a 20-year-old go into? Okay. So if you have a 20s here, 10s and 20s there, so if I have basically, so if I have a bin that says, it's a numerical bin, so it goes from 10 to 20 to 30. Okay, where does the 20-year-old go into? Which one? Does it go into fall under here or fall under here? Bin 1 or
30?
bin 2?
Bin 30?
Bin 2.
10 to 20. Some says 10 to 20, some says 20 to 30. Right? Okay.
Yeah.
So we have to have a definitive rule. Okay. So if we want to be, so this should be a universal language. A statistician in the United States and statistician in Australia or anywhere else in the entire world, when they read this problem, they should know exactly which bin it should go into. So there's a set of universal rule that says that when you have a range like this, and there's a repetition, as you could see right here and here, right? You first include the first number, but do not include the second number, as you could see. Exclude that right here. So they're saying that from 10 all the way to 20, but not including 20, you could go up to like 19.9999999 years. But when you come to 20, you go into the next bin. So far, so good, right? So therefore, then the 20-year-old will go into here, into bin number 2, right? Where would the 30-year-old go into? Of course, then they will go into bin number 3, right? And so forth, okay? So if it's in the cusp, it's in the cusp of 30 20, and so forth, it will go into that next bin, basically. So far, so good? Any question? Okay. Okay, great. Okay, so in interval notation, and Alex, and I believe Alex and Joseph, Joe will actually go over a lot of the histogram going through StatCrunch, okay? In their tutoring session, can you guys go over the variation of, setting different class width and then giving them how the class would change the appearance of your histogram? Can I have you guys show them that? Joseph and Alex?
Yeah.
Thank you. Okay. All right. So here, okay. So here they designated, so in this frequency table, they designated the class bin width to be 10, okay? But it's always up to you to designate that bin width, okay? So histogram is kind of like a art form, okay? The bigger the bin width you make it, less the detail. Smaller the bin width, finer detail, more detail. So as you could see, this is exactly what they did, okay? This is a histogram for bin width of size 10. Okay, this right here is the same data with bin size 5. We notice that it goes from 15 to 20, 20 to 25, 25 to 30, 30 to 35, 35 to 40, and so forth. You notice that this one has much more detail than this one right here, less detail. Okay, it's an R form. Okay, so how do you know which bin size you need to choose? You don't know. You have to actually play around, and Joseph and Alex will actually go through a lot of application and go through the StatCrunch to show you what would happen to a histogram when you change your bin size. Okay, the smaller the bin size, you get too much overload of information, whereas if you make it bigger the bin size, you get none of the information, useless information basically, okay? And that depends on the bin width. Why is it critical? Because when we organize our numerical data, we want to organize them so that we can see a good picture, what the distribution is. And then depending on the shape of the curve or shape of the distribution of the data, we calculate the center and the measurement of the spread accordingly. Okay, if it's symmetrical and unimodal, then we use measurement of the center to be a mean. Whereas if it's skewed to the left, skewed to the right, we're going to use a measurement that it measured the center, or what we call the typical center, to be median. So it is very important that we know what type of distribution that we're working with, or what type of shape. Okay, so far so good. So this is actually a bin size of 5, and they redistributed this right here. And then this is the frequency table, and you see that right there. Okay, so they'll go through this portion right there. Okay, again, bad choice for setting your bin width. We don't want to be setting our bin size to be what? 50. That's useless. Okay, because if you set the bin size to be 50, sure. Okay. So we'll just say that zero, and this is 50, right? How many students of this raw data falls into 0 to 50?
All of them.
All of them. There are 28 of them, actually. We'll just say this is 28. So you only get, That's 50. Okay, this is it. Does that tell you anything right here? You're like, oh, no, it's pretty much all of it. This is a much better graph right here. Okay, this is much better graph right there. It gives you more information, how they are spread out, right? This is even better, right? Okay, but by making it as a 1, your bin size 1, would that actually get you a better graph? Not necessarily. It's just going to be overload of information, okay? So this is another bad choice, right? So not having too much detail and not having too much detail, those are kind of, you know, a bad situation or bad examples or bad histogram, okay? So like I said, it's an art form. You want to make it pretty, right? Have a little bit of detail, but not necessarily overly loaded with detail that you can't actually see all these different type of curves. Okay, so far so good? Any question? Okay, so when we organize our numerical data, we want to put it in pictorial form. Why? Because pictures are worth 1,000 words. It's easy to tell how it is distributed. Okay, one other thing is that there is something called we just saw a frequency histogram up here. Okay, now we're looking at what we call the relative frequency histogram. Okay, relative frequency histogram and histogram are, right, very similar. It's just that one is in what we call the frequency for how many times each, right, class, or what we call the bin, how many number of frequency occur in each bin. Whereas this one is just proportion. Proportion to what? Proportion to the total here as a whole. What percent are between ages of 10 and 20 in your community college that we surveyed? 0.1071, which is approximately 10.71%. Get the idea? Okay. Now, if I put this on side by side, okay, this is actually a side by side, right? Graph of your, this is your frequency histogram, and this is your relative frequency histogram, right? Do you see a difference? Cassandra, do you see a difference?
No.
No, it looks exactly the same thing. The only difference is that this right here is a frequency, 5, 10, 15, whereas this one right here, I believe this is 0.1785, this is 0.3571, and then this is 0.5357. Okay, so the only difference is that your increment here, your y increment, is actually in decimal form, whereas this is actually a whole number frequency. Okay, relative frequency. So we have a relative frequency and we have a frequency histogram, but it should be identical. Okay, when you graph it, it should be identical. Long as your width, right, your class bin size is exactly the same, they should be exactly the same, these two. Okay, it shouldn't change. They're identical. Okay, because a lot of the time we want to know about the proportion, percentage. So that's why it's considered to be rather than a frequency or relative frequency. To figure out the relative frequency, you have to add up the total, okay, as a whole, right? And this is the part, right? What part is it? What percentage is it? And you should know how to actually calculate that. Okay. All right. So the most important part about this section is how to identify the distribution. What type of shape you're working with. And depending on the shape of the curve, we can actually figure out how to calculate your typical center. If it's normally distributed, or if it's skewed to the left or skewed to the right, or bimodal, it all depends. If you have a normal distribution, your typical center will be mean. Okay, this is the average, what we commonly known as the average. Okay, but in statistic, average, there's actually 3 average: mean, median, and mode. Okay? So this right here, when you skew to the left or skew to the right, our typical center will be our median. Okay, so you notice that the center is calculated differently depending on the shape of the curve. That's why it's so important to identify what type of shape of the data that you're dealing with. That's why we graph it into a histogram, we graph it into, you know, stem and leaf plot and so forth. Okay, over here, okay, what's cool about this right here, if I erase this, delete, what I could do, I like this. I just want to have you guys see. Okay. And then I can put it in here. Ah, nope. That's not it. Let's erase that portion.
If you guys have any questions, you can type it in the chat in case you don't want to interrupt. You can also play your hand raised, just to let you guys know.
You notice this right here? This is actually what? Stem and leaf plot that we just saw. Notice this right here. If I actually do this, and then I do this, like that, it actually becomes exactly the histogram. Look at that. It's just a histogram in a sideways form, right? Again, the difference between the stem and leaf plot and the histogram, one's in horizontal form, one's in vertical form, okay? But stem and leaf plot actually retains the raw data. What are the raw data? Oh, I got 18-year-old. We have 18-year-old, 19-year-old, 20-year-old, 20-year-old, 21-year-old, okay? Histogram loses that raw data. You're like, I only know 3 people that goes into here, but I don't know exactly their ages unless I have the raw data. If I don't have the raw data, I don't know. It loses it, okay? So far, so good, okay? But this right here, stem and leaf plot, right, is inferior to large sets of data. When you do this, right, if you have like, say, 10,000 data, this is not good. Then you would have to write every single data value, 10,000 data value. Whereas you could say this and just make a box, right? A bar with, you know, 10,000 frequency there, right? Get the idea, right? Okay, much easier, much useful too. All right, okay. So the key, right, component, key things that you want to realize when we're actually graphing our stem plot or histogram is we want to look at the shape. Okay, that's the most important thing. Once we recognize what shape we're dealing with, we could actually calculate we're going to be calculating the center and calculate the spread. Okay, so what is a shape? The shape is a distribution that tells us generally how the data look or behaves. What value comes up the most? Is there one peak or many peaks, right? Is it symmetrical or is it non-symmetrical? Is most of these data plot onto one side or the other side? And we want to actually answer all these questions, okay? Upon knowing that, right, then we can actually calculate the measurement of the center, what we call the typical center, right? So what is the typical value of the distribution? How do we figure out that? What's one value would best represent all the data depending on the shape and type of distribution? There are a few different ways of calculating this, deciding this right here, okay? And Joseph and Alex will actually go over the calculation process and show you how to calculate this in StatCrunch. Got it? Okay. Of course, spread. Spread is very, very useful. Okay. Okay. So notice right here. Okay. So the definition of your spread. Spread describes the variation of data numerically. It tells how spread out data is from the center. Once we figure out what type of shape of the curve, once we figure out the center, we want to figure out from the center, how is the data spread out? Is it spread widely from the center, or is it condensed to the center? Doesn't spread very much. As you can see, your graph ACE has a more spread, or what we call more variation, okay? Compared to what? B. So far so good, okay? B has less spread or variation, okay? Later on, you're gonna be using technology to calculate this, and that number that we are looking for, this is considered the numerical value to be considered the standard deviation. Okay, you're going to be calculating the standard deviation. The more spread you have, the bigger the standard deviation. Less, right? Less spread you have, right? Smaller the standard deviation. So let me give you guys a question. Patricia, let me pick on you for today, right? So if you think about the age variation between a high school students and community college student, which one has a more variation, or what we call the bigger standard deviation? Which one has a more variation, high school student or college, community college student?
Community college.
Why community college? So high school and community college.
Because for high school, you have to be like around a certain age to.
Can you tell me the range of age approximately?
I would say like about from 13 to 17.
Or probably 14, usually 14 to 18, right?
Yeah.
But there are people who are maybe a little bit younger coming in, maybe hasn't passed their, right?
Mm-hmm.
So you could say, and there could be a super senior, right? That has been held back maybe, a couple of years, right? So we could range from maybe 13 to 20, whereas in community college, you could range from what to what?
Like 18 to.
What do we just saw from here? What do we just see here? Let's go all the way up here. So what do we just see there?
49.
49. You could even have I had actually maybe over 60-year-old student in my class, which is good, right? So they could actually range from 18 to 70 years old probably, right? Anyone could attend this, right? Okay, attend community college. So therefore, which one will have a bigger standard deviation?
The community college.
Very good. Give her an MVP, right? Point. That's a good thing, right? Okay. All right. So first we'll get any question. Okay. Okay. And you're gonna be learning how to actually calculate this. We're not gonna be so in my class, if it was a traditional class, I have everyone actually calculate this by hand. Okay, but in this class, this is 6-week class. I'm not going to emphasize you calculating this by hand. Maybe Joseph might show this, one time how to calculate it, but majority of the time you're going to be using technology to calculate your standard deviation, or what we call variation as well. Okay. So first again, okay, Joseph and Alex will be the go-to people and asking them how to actually do this on StatCrunch. Okay, so first again, distribution. Okay, the type of distribution that you most likely will see in this class is going to be the normal distribution. This is one of the most important distribution out there. Okay, normal distribution, which is symmetrical. Okay, symmetry, which means if you cut it exactly in half and fold it in half, it's a mirror image. Okay, your left side look exactly like the right side. Okay, symmetrical, and one mount. We have one peak. Okay, so this is an example of, this is an example of a normal distribution. So watch here. This doesn't look very much like a normal distribution that I describe over here, right? Okay, but this is just one example of it. Notice that this is not a perfect match per se. This is because data varies, right? But this is close enough to the general feature to easily still be considered to be normal. So when you graph something like that, it actually becomes what we call a normal distribution. Oh, that's a horrible. Okay, so, but get the idea, right? Okay. So here, there's another symmetrical graph, okay? Similar but not normal example is symmetrical if you cut it exactly in half and then fold it in half. Your left hand and the right hand side are exactly the same, but it's not unimodal, okay? It doesn't have one mount, okay? So therefore, this is not considered to be your normal distribution, but it's symmetrical. This right here, okay? If I erase this, looks very much like this right here, but when you kind of outline this, it actually looks like more like a triangle rather than a what? A bell-shaped curve, right? So the symmetry, unimodal, but not quite normal. So therefore, this will not be considered to be a normal. Again, other distribution that you will see here is called the skew distribution, okay? Skew distribution. Okay, we have a left skew distribution. We have the what? Right skew distribution. Okay, and how can you tell if it's a left or right? You could tell by the tails of the right, where the tail goes. If it goes to the left, it's left skew. If your tail goes to the right, it's a right skew distribution. Okay. One common example that we use in statistics is your income distribution. And this is a hot topic nowadays, right? There's a huge demonstration going on with the race and an income distribution, unequal income distribution, right? And so forth, right? And you notice that people who have who makes annual income of 20,000, 40,000, 40K, 60K, 80K, and so forth. Majority of the people falls between here. And then there are tiny percent that goes all the way to what? Millions, tens of millions, hundreds of millions, even billions of dollars, like Jeff Bezos, right? Okay. So we have inequality in income distribution is skewed to the right. Okay. My challenge to you guys is to kind of think about example of a left skew distribution. Okay, so far so good. Okay, that's challenge to you guys, right? On your own, kind of think about this one, right? And then let me know next time we meet, right? Okay, now there is another distribution that I like to talk about. Okay, we have what we call the uniform distribution. Okay, what do you mean by uniform distribution? Is all straight across. It's about the same. Okay. So far, so good. Any question? Okay. What is a common good example of a uniform distribution? We just, where is Alex? Can I ask you a question?
Yeah. Oh, me or the TA?
No, Alex Newport?
Oh.
Yeah.
Yeah. Did you
Sorry, when you say Alex, I thought you meant Alexis.
No, Alex.
Me too.
Alex, did you guys go over the DICE applet with them?
Yeah, I believe we did that last time.
Okay, so remember when if you haven't done it, can you kind of go over it and then go through the kind of sample of, say, 60 tosses, 100 tosses, 200 tosses, and kind of graph the histogram for them? Then they'll see eventually in a long run the DICE becomes what we call the uniform distribution. Why? Because DICE has numbers, right? Okay, and those numbers are 1, 2, 3, 4, 5, 6, right? What's the probability of coming out 1? So basically, this is this one, right? What's the probability of coming out 1? If it's a fair die, what's the probability coming? How many sides do we have altogether?
6.
6 sides, very good, right? So out of 6, what's the probability of coming out 1?
1 of 6.
1 out of 6. What's the probability of coming out 2?
1 out of 6.
1 out of 6.
1 out of 6, right? Coming out 3, 1 out of 6. It's the same probability. So if you actually toss it 600 times, it's most likely that it will come out 100 1s, 100 2s, 100 3s, 100 4s. It's evenly, right, distributed. So that's why it's called a uniform distribution. Get the idea? Okay? Uniform distribution. Of course, there are distributions like bimodal, where we have 2 humps, okay? Okay. And we have what? Multiple hump. What about if you have exactly three humps or 3 peaks? What would that be called? If you have 2 humps, it's called the bimodal. What about 3 peaks?
Multimodal.
Multimodal. Oh man, you guys don't fall for it. You guys are too smart. Okay. Usually, what other students will answer, if it's a bicycle, right? Then the next one will be what?
Tricycle.
Tricycle. If it's a bimodal, then if you have a 3 hump, then you're gonna say what?
Trimodal.
Trimodal. But in this, right, there is no such thing as trimodal. Anything bigger than 2, right, is called a multimodal. Oh, you guys are too smart. You guys don't fall for my things, right? My trap. Oh, gosh darn it, right? Okay, all right, so here, this is a popular time, right? We're in and out on Alondra Boulevard, right? Who visits there often? Oh, I don't have time to go there. Oh, it does smell so good every time I drive by there, though, right? Right? So you notice that this has 2 humps. I would have thought it would, you would have more hump in the lunchtime than the dinner time, but I guess I'm wrong, right? So there's a lunchtime and dinner time. That's the lunchtime rush and then the dinner time rush, right? So this is an example of a multimodal or bimodal in this case right here. Okay. So depending, like I said, all these distribution we have to identify. And once we identify that distribution, we're able to actually calculate your center and calculate the spread. Okay. And one way to calculate the center, if is what we call symmetrical distribution, right? And unimodal, it's a normal distribution basically. Okay. Is to use what we call, this is your measurement of the center, typical center is the mean. Okay, and basic is commonly known to you guys is the average, but it's a wrong terminology. There are actually 3 different averages. Mean, so averages are known as, they're all averages. Right? Mean, under average, these are all average. Median and mode. Okay, these are all 3 different averages. The most commonly what we're accustomed to is the what? Is the mean. And how do you calculate the mean? Which means how do you calculate the average? Sorry. You add up all the number, right? And then what do? You divide by the number of data. Okay, there's 2 types of mean. We have a population mean and we have a sample mean. Okay, it depends on what type of data you have. If you're dealing with a population data, then we're going to be getting a population mean. And if referred to in Greek letter, mu, right? If it's a sample mean, then it's considered to be X bar. This is called the X bar, X with the bar on it, right? Okay, that will be your sample mean. Okay, if you notice right here, the star, big star with the red crossing it, it says we need 2 versions here, as later we will be using as samples to answer questions about population. So it is important to be able to distinguish between the 2 quickly, which is your population mean and sample mean. Okay, population mean, if we consider that to be what we call the parameter. And I think I said this either in the first class or the second class. Okay, of course, this class is all about, what is this class? What's the title of this class?
Stats in motion.
112.
Math 112 statistics, right? Intro to statistics. And what is statistic? Is sample. Okay, so we're analyzing and studying sample data to represent the population. If we have the population data and population distribution, we don't need statistic. We don't need this book. You don't have to learn statistic, but it is impossible. Like I said, it's impossible to get the population data. Okay, a lot of the time it's very difficult to get the population data. Okay, all right. So here is the what? How to actually, this is just an example of how to calculate your measurement of the center, right? Which is your mean. And I'm not going to go through this. This is your measurement of the spread, which is your standard deviation, your variation. How is it spread from the center? Okay. Like I said, Joseph, if he has time, if you have time, do it, right? But if you don't have time, forget about it, right? Going through Joseph and Alex, right? Okay. If you guys have time, kind of showing the step-by-step process, going through the table, and I like this table here, x minus x bar, x minus x bar quantity square, and then going through all that. Okay. So far, so good? Okay. Yeah. And then figuring out your sample standard deviation and population standard deviation and differentiating it, okay? All right, there's a lot of information here, okay? So you got, of course, like I said, this is summer class right here. This is a whole semester condensed into a single 6 week, which means that this is 3 times as fast. So you got to put in 3 times as the work. Okay, it's up to you guys to put in that work to grasp the material and information. Okay, and Alex and Joseph is going to be there every step of the way, helping you guys out. Okay, so far so good. Any question? Okay, now I'm gonna actually toss it to Joseph here, and he'll become the host, and he'll answer any other question you have. Okay, all right. So I'm gonna leave you guys for today. Okay, have a nice day or have a nice afternoon. Okay, and I'll see you guys next time. Okay.
Bye.
Cool. All right. Take care, everyone.
Put up Stack Crunch. Do you guys remember where the roll dice is?
Isn't there simulations? Or there's the simulations button, right? They can click.
Yeah, there's simulations. That's for if you want more than 50 or 100 at a time. I think right now we wanted to do the experiment one, but yeah, we'll do the experiment. Because the experiment goes through it once. We're going to go through it a bunch of times. I say like, what, 25 times, Alex? Or more?
Yeah, 25. I think he had said like 50. But yeah.
I could do 50.
Sure.
So see how tedious this is in getting information. Now we know that we have like other tools available.
You said that simulations one would do it all instantly, right?
Yeah.
Okay.
Conley wanted us to show you how tedious this is in collecting data. So we got 5 more rolls. She told us to have it to write it down, but we have this tool right here that says analyze, and now we have a column with how they're all supposed to be rolled. So 5, 2, 1, 3. So yeah. Do you guys go for it?
I think we went through this.
Okay.
So let's just graph it at this point.
Okay, so we want to make a histogram. We go to graphs. We go to histogram. And our column is called roles. So we click on that. And we want to see the value above that bar. So we click on there. And that's it. Usually everything else is taken care of with by StatCrunch. So while Professor Yi was talking about the bins, we can choose where to start from and the width of it. So we'll show you the normal one, how StatCrunch takes care of it. So these are the bins. Can everybody see that? Does anybody have any questions about these? Does it look wrong? What do you think this histogram should look like?
Like the type.
Say that again?
Like
Should be touching, right?
I think the more that you roll the dice, the more that the lines will get even.
Yeah.
Correct.
That's what I was going for. But yeah, you're right. They should be touching because it's a histogram. I don't know where that went wrong.
I think it was in the settings, probably.
Edit.
But yeah, the more values you have, so this was just 50, but if you have like 100 and something, then
1,000, yeah.
Yeah, the bars will eventually just be the same-ish.
Yeah, so this is kind of a weird graph. And then how Professor Yu was saying, if we change the bins, the information kind of becomes useless. So we'll start at 1, and we'll make the widths, 2s? I can't see. So the information kind of starts getting weird. It doesn't really make sense. So from here, it's 3 to 5, not counting 5. So we have 14 rolls, and that's less information that we're getting from this compared to the other graph. So that's if we make the width bigger. If we make it smaller, we can't really make it smaller because it's a die. We can't put 1.5 because it's not going to pop out. But with other information where you have numbers like that, it will make it, you're going to get a lot of information overload, how he was saying, but it's not really going to tell you anything. So again, you have to find the right bin width. I think that's what he wanted us to go over. And the uniform distribution, how we were saying in the beginning that they should all be the same level because we just have a small number of rows, so that we're not really getting the information how it should be. So yeah. Do you want to pick who's gonna show this, Alex?
Let's go with Nico.
All right. Nico, let me have you open up StatCrunch and then share your screen, okay?
All right.
Let me know when you open it.
Hold on, I just gotta sign in real quick.
Okay.
Does anyone have any questions while he does that? No,
Have you guys? Sorry, go for it.
Are you guys gonna be able to tell us how to find the mean?
Oh yeah.
Yeah,
Sorry.
I'll go over that right now.
Yeah, because when I was looking at the videos in the module, I didn't really understand it. Like, I don't know if I missed like a step or something.
Okay, so you want to do it by hand.
I just want to make sure like I'm able to know.
Do you want me to show the StatCrunch version right now, Alex, or you want to do the hand version?
So let me see. Nico, are you signed in yet or no?
Yeah, I got it.
Okay, so let Nico share his screen and finish that, and then we'll go into the other thing after.
Okay. All right, so you have to go to where from there? Yeah, we'll do that one. That's fine. Are you pushing space? Oh, okay, there you go. Do you mind unmuting and going through what you're doing?
Yeah, I think I clicked the wrong.
Yeah. So go to experiments.
Oh yeah, that's where it's at. There we go.
The simulation is for when we want to do bigger rolls, but right now we're just gonna go through this.
Okay. You want me to do 50 again, or?
We can do 25. All right. So now how would you make a graph? A histogram. There you go.
Do you want me to change this or not?
No, that's fine. It'll take care of it. So just put compute. I think we're good from there. And then now we have the histogram. So yours came out how it was supposed to with the numbers right next to each other. So this one's not a uniform distribution, right?
Oh, sorry. I think my thing was muted because I couldn't hear anything.
Okay, that's fine. So yeah, that was it. Nice job.
Okay.
Oh, so you get a spin for that, but we'll do that later. I'm just gonna write it down on your thing.
Okay.
Since we're probably gonna run out of time, or we'll see. So Joe, share the same example that you did with them, and they can write down the information, and then I'll write it down after.
Okay. There it is. So what do you want them to write?
Basically, they're trying to find mean and standard deviation by hand, and we're just
Okay, so you want me to give them the answers, and then you're gonna have them work it out?
No, what?
Like, you want me to put the answers?
No, don't put the answers. Number 7, the relay race.
Oh, okay, okay.
That one or
That's
something
okay.
else. Yeah, show them an example, and then we'll go through standard deviation.
Okay, I thought you meant from the StatCrunch. Okay.
I don't know.
So let me do
Afterwards,
this.
we'll do StatCrunch.
I don't know where I put it.
I don't know. You have too many tabs open. I have no idea.
I do. Sample questions. You want me to do the same 2 as last time?
Just one. We're just doing one. So maybe just do the first one.
Okay. All right. I'm loading it. Okay. So right there. Number 6, your basketball team has 20 players. here's the points per game for 5 players in the 2019 season, and then it gives you the players and the number. So go ahead and write down write down that information. I don't know where all the videos went, but okay.
What's that?
What did you want me to do from here?
I'll share my screen from here on out. We're just gonna find the mean and we're gonna find the standard deviation.
Okay.
After that, we'll do it on StatCrunch because that's what they're gonna use mostly.
Okay. So
Just stop
everybody-
sharing.
Yeah.
Everyone got that?
Anyone wrote those numbers down?
Nah.
Okay, I'll share it again.
Okay, so just write them down and we'll go from there.
Just the numbers, right?
Yeah, just the numbers. So the 25, 21, 24, 23, 22. Y'all good?
Yeah, got it. Thanks.
Okay, so stop share.
Before we find the mean and the standard deviation, is this a population or a sample? I can share it again. Sorry, so we can look at the question.
It's a sample, right?
A sample, right? Because the
Yeah.
entire team is 20 players, but we're only getting 5 of them. So that's the formula that we're going to use. Nice job.
Who said that?
Which
Alexis?
which sample formula we're gonna use? Or are they separate? Like,
Yeah, so
okay.
we have,
So there's population and sample, right?
yeah, we have 2 types, and it's population and sample. So the one
Alright, I
for
get it.
population, remember, was mu, right?
Yeah.
But in
That's the
this
population mean.
And then for sample is X bar, right?
yes.
Nice job.
Okay, so can anybody tell me how to find the mean?
You add them all together, right?
Add them all
All
up.
the variables, and then you divide it by the total.
Yes.
The total.
Yeah. So in this case, the numbers that you wrote down, what would be the mean?
23.
Yeah.
Okay, and that's X bar. 20. That's how you find the mean. You just add them up. So this means sum. It's sigma and of the x's, and then you divide it by n, and it's the number of values that you have.
Yeah, the sample size.
Yeah. So then after that, we're gonna use the equation for standard deviation. We said sample, right? Yeah, that's what we're doing. So we have this guy. You guys recognize this formula or equation? Yeah? No? Maybe?
That standard deviation.
Yeah.
There. Yes.
The sample standard deviation.
Yeah. So basically what we're doing here is we're making a chart. This is in the modules. And we have all the values of x, which were the 21 through 25?
Yeah.
We could put them in order. It's not a big of a deal. So you do that. And then here we have x minus x bar. And we already said that x bar is 23 from the previous step. So we're gonna do 21 minus 23. And then we're gonna do 22 minus 23, and so on. Can anybody tell me the values that I would be getting right here? So this one's -2. What's the next one?
-1.
Yeah.
Okay. So, Ariana, what's the next one?
0.
Okay. Anyone else? Next one?
1.
Uh-huh.
And then 2.
Yeah.
Okay. So then after that, we have this guy here, which means that,
Real quick.
Yeah.
The sum of all those numbers should equal 0. I don't think you went over that. So summation of all those numbers, a -2, -1, 0, 1, and 2 should be 0.
yeah, so the sum of these numbers is what he's saying. When you add them up, it should equal 0. Cool. That's in your book too. You should kind of read through it and understand that. But so here we're gonna have these numbers squared.
Make another table with that squared, so that way they can see it.
There.
Okay.
I have room for that.
Okay.
So then that's ugly.
How do you want it to round?
Sorry.
When we get to like the final answer, how do you want us to round?
The question should specify, but as long as it's within that range, not completely off, it's fine. But it probably, if it wants a specific thing, it'll say it on the question.
Okay.
Yeah. It almost likely say like a decimal point too. I don't think it'll say a whole number, unless maybe we're talking about students. But we'll get to that bridge.
Okay, so we get that after we square the numbers, and then when we add them up, we add these guys up, we get 10, right? So that's the numerator. I feel like I've already made a mess of things. Anyway.
Oh, you're good. It looks good.
Okay, so then we have the square root situation. We already said the top number is 10. What's the bottom number?
5.
Uh-huh.
Somebody said 5?
Yeah. But
Okay,
5.
cool.
Wouldn't it be 5 minus 1?
Yeah, 5 minus 1. Sorry, I was letting him finish.
Oh, okay.
So it's 10 over 5 minus 1.
And so we're going to get 4,
Yeah.
which is equal to 2. So that should be your final answer for standard deviation.
Wait, what did you do? It's 10 over 4.
Wait. Oh. Yeah. That's because I had already left the 10 up there. Hold on. Okay. So 10 over 4.
Yeah. And we put that into the calculator.
1.6.
1.6.
That's
Okay.
right.
Who agrees? Who disagrees?
Yeah, that's right.
Okay. Does anyone have any questions? Anyone got like something completely different? No? Good? Okay. So basically those are the steps that you would go through for standard deviation. You see how there's a couple steps. I didn't write this one down, but that one was like adding all of them, just to summarize, adding all of them and dividing by the number of values. We got that. And then after that, we just plugged in into the little chart
Yeah.
here. And yeah, but in this class, you'll be dealing with a lot more values. So it's harder to make or more tedious to make a table of like, let's say you got like 50 values. That would take forever. So
I'll show you what to do in that case.
yes. Let me stop sharing.
This is usually how you're going to go through it too. You're not going to really be doing those by hand. So,
Yeah.
especially because it's a 6-week class. Yeah.
Yeah, in a normal class, you would actually go through it. It's kind of good to know it in case you don't have that many values, and you could just do it real quick
Okay.
by hand.
Share screen. Okay, so when I open up StatCrunch, how we did it for the StatCrunch exercise, just pick whatever you want. I'm going to put movie budgets and box office earnings because I know they have numerical data. Because histograms are for numerical. So I'll have it loading. Okay, so what would be a numerical variable in this data?
The year, budget.
The year would be categorical, but the budget, yeah, numerical. So we go to graph, go to histogram, and we graph the budget. I'm just showing you what it's going to look like, so that our values make more sense. Okay.
So that, hold on. Oh.
Sorry, go for it.
The step that he did right before he clicked compute was that he had the value, he clicked so that you could have those little values above the bars.
Yeah.
So that tells you more information. And when you make a graph, it gives you the little options. So. Yeah.
So we didn't really go over this in class, but did we? I feel like a little bit. What kind of graph is this?
The graph? It's a histogram,
Yeah,
histogram, right?
Yeah. Yeah, it's right skewed, right? Because the tail is on the right.
Oh, the shape? Yeah.
Yeah, my bad. The shape. There you go.
Yeah, the shape.
That would have been a better explanation. So where would our median be if you just had to eyeball it?
This part confuses me on like eyeballing where.
Yeah, that's what
I
I'm
would say
asking.
like around, I don't know, I'm just guessing, probably like around 80 because like the right, how it's skewed and it's like very skewed. So that's
Yes.
that
So it would be
affects it a
somewhere,
lot.
yeah, somewhere over here because there's less values, right?
Yeah.
So it'd be somewhere in this direction. And then our mean would be closer towards the tail. So in this case, our mean would be greater than our median. All right. So the way we can look at that information is we go to stat, we go to summary stats, columns, because that's a column that we're picking. If it was a row, it would be row. So for our budget, and we want to see our sample size, our mean, our standard deviation. Oh, sorry, I got to do that again. Where is the, I'm looking for the median. There you go. So we have that information. That's the stuff we're working on right now. Okay.
How do you like choose more than one thing? Because for me, it only lets me like click one at a time.
Okay, so we'll do that again. Columns. If you want to select, oh, sorry. Budgets. If you want to select everything, you just pick the top one and go all the way to the end and put shift. But we usually don't want everything. So I click the first one and then control click the rest of them. So I hold control down. I click mean, standard deviation, and then I scroll down and look for whatever else I'm looking for. But sometimes it's like a little, it goes farther than it's supposed to.
To get there, where'd you go to? You went to data, right?
To stats.
Okay.
Summary stat.
All right.
And then columns.
All right, thank you.
And I'll have that information right here. So our mean, how we said, will be closer to the right and it'd be more than our median because our median would be somewhere over here. So actually it's like 18. So it's like somewhere right here. It looks like it's going by 20s, 25s. Yeah, by 25. So it's like our median is somewhere right here. Because most of our values are on the left. So if this was the other way, our median would be closer towards the right. And our mean would be towards the left because it would be left skewed. Does that make sense? Are there any questions?
Anything? Just future reference too, while we're in lecture or on here, if you guys have questions, you can also type it in the chat. Because I know Professor Yi, he'll go like talking and talking, maybe he won't like notice it, but one of us will probably look at the chat and notice questions, and you guys could ask him stuff too.
So the standard deviation, most of it we're gonna do right here. Sorry, Alex, go for it.
Yeah, you want to do one more example on this?
We can have somebody else do it.
Yeah, let's do that. Who wants to volunteer for a spin? If not, we're gonna volunteer someone, but who wants to volunteer?
I'll do it.
Okay. You get more spins. Nice job. I'll stop share. All right, go for it.
Like any random little thing.
This set? Yeah. So if you put it right now so I can see what you're picking. All right, so go back to StatCrunch. You can just click the StatCrunch on the left or next to the P. Down.
The next tab.
That was fine. Yeah. Data sets.
Yeah.
So you can search for whatever you want, or you can pick one of those. It's up to you.
Usually they have you pick something that is of interest to you, so.
Yeah.
Yeah.
So maybe your sport or, okay.
Mm-hmm.
So I could do number of votes, right? Because that would be.
Yeah. That one seems to be missing a lot of columns though. So let's see if there's a better one, maybe another row or another column, sorry. You can scroll to the right at the bottom. Yeah. So see if there's anything else. So maybe the home run percentage or how many RBIs they had. That'd be cool.
I'll just do.
Okay, so now that we found our variable, yeah, stats, summary stats.
We'll have to graph it first, right, or not?
You don't have to. I just graphed it so you can see visually what it is, and yeah. If you want, graph it, go for it.
All right, I'll do that first.
I don't know what the H is, but it's fine. Okay.
So then you get summary stats. Yeah. So what do you want me to find? Just the mean and the.
So try all of them, not all of them. Try the three or four that he tried, so that you could kind of get.
So the N, the mean, the standard deviation, and the median. Okay, let's scroll up before you put compute because you haven't picked a column yet. And then put compute. All right, there you go. So this data is a little messed up because it's not right skewed. It's not really
left.
So it's symmetrical.
What was it?
Bimodal?
Yeah, bimodal. Would that be bimodal?
I don't know because I think it still needs to have it going down on the left. So the 67 just goes up and then it goes down. Oh, I think you still need information on the left of the 67. So I don't know if this is really bimodal either. Yeah. But there you get your standard deviation, your median, and your mode. I mean, your median and your mean. All right, nice job, Nico.
Nice job. Okay, so I could do the spins right now. And then if we have time for more stuff. Does anybody have any questions or no? I'm gonna go with no.
We could try the worksheet we were supposed to do, the larger or smaller. Now that I kind of have a better grasp of it.
Okay,
We can do a couple of those.
sounds good.
Okay. So here we're going to say the question is what makes the standard deviation larger or smaller? So there's 15 graphs, but we're not going to go through them all. So we want you to indicate which one of the graphs has the largest standard deviation and which ones are the same or smaller. And then identify the characteristic that makes the standard deviation larger or smaller. So for this first graph right here, which standard deviation do you think it's larger or, is it A or B? I can pause the screen. Any ideas? So do you guys remember what the standard deviation means?
The average, like distance.
From what?
The like.
Say it again.
The distance from the mean, right? Like each point.
Yeah. So with the guessing of it, when it's symmetrical, they're usually going to be in the same point. But when they're right and left skewed, they're going to change. The only one that's going to change is the mean, not really the median. So this one, it tells you where the mean is. So that kind of gives you a hint of which one is larger and which one is smaller. So if you had to guess, which one do you think has a bigger standard deviation?
A, because A is not as symmetrical as B.
Okay, does anyone
I was gonna say B.
Yeah,
because it's skewed, right?
Yeah.
Skewed left, so it's like the distance is more apart.
So let me make sure on that. So yes, B is larger. And it was because of that, because the mean would be more towards the skewed side, so it'd be more towards the left, and it would make a bigger standard deviation. Does that make sense?
Could you explain it a little more?
Yeah. Oh, okay, so let's look at the graph. I gotta put it up bigger. So the A looks a little more symmetrical, right? So that means that the median and the mean are going to be in the same place. So it should be 257. So like somewhere right here. It's kind of evenly distributed, if that makes sense. Whereas when we look at this one, it's more towards the right for some reason. It should be more towards the left.
I think your screen's frozen if you're moving around.
Oh yeah, sorry.
Yeah, I think I'm pretty sure you paused the share so you could look at other stuff, no?
Yeah. Okay.
Oh, there you go.
It'll probably be more clear as we do more examples. I think.
Yeah, I think so too. I agree.
So I'm gonna pause the share right there. Okay, so what about number 2? Which one do you think has a larger standard deviation and why?
You would have the larger standard deviation.
Where?
B.
B?
Yeah, I'll guess B too.
B, right? Because they're separated.
The part, yeah.
Yeah, so they're going to have a larger standard deviation. They're not all going to be the same answer because they're different graphs, right? So the first one was more, you could see that there are 2 different kind of graphs. They were symmetrical and one was skewed. This one doesn't really follow that category, but we can see that because they're apart, they have a larger standard deviation. All right. Are you guys able to see 3?
Yeah.
Yeah.
whatever.
Don't those have the same
So yeah,
deviation?
and why?
Because they're both the same distance from the mean.
Yes, so they're both the same identical graph. They just moved over 2, or one starts at 0, one starts at 4. All right, so nice job. What about 4?
Would that one be B since A is what was it?
It's it's
Unimodal.
A is uniform.
It's 4 more, right?
They're symmetrical, right?
Yeah, A is symmetrical. So would that mean that it's bigger or smaller than B?
Smaller.
Smaller. So which one's larger?
B.
B, right? Because since it's all uniform, they're all going to be near the score that's supposed to be, 2.5. Okay. What about 5 and 6?
Well, the mean, when we're looking at these, the mean will help us decide which one's bigger, right?
It depends, because look at number 5. The mean is 2.5, but there's less data. It could help you, depending on the type of graphs it is.
Okay.
Yeah. So if you can see, like, if they're right skewed, left skewed, and symmetrical, it's a little easier to distinguish with the mean. But when you get like those funky graphs where like they're separated or there's only like 2 sets of data in it, it's a little harder to use the mean. But you can see it based on the graph. So you have to see what's given to you and what you can use.
So what would 5 be?
So which one do you think has the larger standard deviation?
B.
B, right? Because it's separated. Again, A, they're all going to be around the same area because they're all equally apart from each other, and it's uniform. While B is separated, and there's going to be a larger standard deviation of the data. So that's some of those examples. We'll stop right there, and I think we're giving you this to look over. So yeah.
What would it be for 6? Hold on. That caught my eye.
Is it A?
A.
Let me make sure.
I think
6.
it's A.
Yeah, 6 is A.
Mm-hmm.
Let me explain. Because of that distance you have right there, and then the other one's uniform, so it's going to be more closely to that mean. So it'll have less of a standard deviation. All right. Does that make sense, everybody?
Yeah, you guys are good?
Yeah, that makes sense.
Okay. So I'm going to stop here. What did you want to do, Alex, for the last part? The spins?
Yeah, the spins.
Okay.
The spins, and if we have time, I'll ask you. Well, let me ask you a couple questions, and then maybe you guys could get more spins. Okay, so what does the mode tell us? Anybody? In your own words, or whatever.
Used.
What was that? Can you repeat that?
The value that's most frequently like say there's like 325s. That's the most value in the
Data, yeah.
Yeah, good job. What is the median?
The value in the middle.
Yeah.
Mm-hmm. Do the values have to be in order for us to find the median?
No.
Yes.
The answer is yes.
We have to find what value's in the middle, and that involves us putting it in order. So if they're random, we're not really going to get what's in the middle. We're just going to get what's in the middle for that random order.
Yes.
That doesn't mean anything.
What is the range?
the maximum subtracted by the minimum.
Good job. Okay, and then Is a histogram the same thing as a bar chart?
No.
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 No. Good. I don't know who said that, but good. Okay, so let's go to the spins since we have like 6 minutes. Let me see.
Are you guys all caught up on the modules? Everyone's good on that? Any questions on those?
Not really.
No.
Okay.
So I
Wait,
have
how
Thursday, right?
modules?
Say that again.
How often are the modules?
I think they're going to be every day.
All right, that's good.
I don't know if the weekend you'll have something, but so far it's been every day, Monday through Thursday.
So we gotta. Is Thursdays due on Thursday or is Thursdays due on Friday? If that makes sense.
It's due before class.
Yeah.
Okay, so the one that says Thursday is due before class. The one that says Friday is due before Friday's class.
Yeah.
Okay.
Okay, so especially before I do this, because if you're looking at information for Friday, if Friday you happen to do like some kind of experiment or applying the information, you can't apply information you don't know. So it's better, well, it's highly recommended that you watch the videos and read everything before Friday so that when they're doing the experiment, you're like, oh, okay, I can relate the information better and actually learn something. Okay, so Cassandra gets 2 spins.
Write them down, or you got them?
I got it. That's fine.
Okay.
So she gets 3, and then she gets 5. Yay. You should play some music during this. And then,
You have the audio.
okay. Sarah gets 2. So we got 5 and 5. Nice. Nico gets 3. 5, 1, and 3. And then Patricia gets 2. By the way, I keep track of these like during class too. So if you guys are participating, asking questions, stuff like that, I add spins to your name. And this is Alexis. He gets 3. 2 and 2. Okay. I'm gonna write those down. Good job, guys. Does anyone else have any questions? Anything that's not clear? You guys got 3 more minutes.
Right now they just sent out a text saying that part 1 for module 4 is, so do we do that before tomorrow's class, right?
Yeah.
Okay, cool.
A text on Pronto?
Yeah.
Wow.
Tomorrow's at 10 a.m., right? It's not.
Yeah, it's 10 a.m. I would make sure on Canvas, just to be sure, like with the time. I know it's kind of confusing, but it's less confusing if you just find your team name and just look at the times, the date, the times, so it's formatted so that you get the least amount of confusion.
Would these times be like around the same times as every week?
They should be, yeah, relatively similar, yeah.
Yeah, I think Tuesdays and Thursdays are the 3 to 5, and the Fridays are 10 to 11:50, right?
I'm gonna check real quick. Give me 1 second.
Not Tuesdays, Mondays and whatever
Thursday.
it is. Yeah.
Mm-hmm. Yeah, but just make sure you look at the modules when they come out. You can always like go back and review it later if you've studied too far in advance, because it's easy.
Yeah, for tomorrow it says 10 a.m. to 11:30.
Yeah.
Also, who has what are the recordings for that? Like, you know, this is being recorded right now. Are we going to be able to view this, or who's it being recorded for?
It's for you guys at the end of, I think once we're all done, they edit them out, make sure that everything's good, and then they put them under where it says mandatory links, I think. It's right under the day. So Thursday, it'll be at the bottom of it, and there'll be a couple links that you can look at. This should be
The
one of
ones
them.
that say links to be posted. Those are like you go there and then they post the links.
Yeah.
Yeah. Let me see.
When you
I can
say
share-
we're all done, are you talking about the end of the quote unquote semester or the end of the class, like this class we're having right now?
Say that again?
When
It's
you
at the
say,
end of the class.
okay, thank you.
Can you guys say that again? You guys both said it at the same time.
No, she answered my question.
Oh, okay. Cool.
What happened? This thing freaked out. Okay, there we go. So we have that. You guys can see my screen, right?
Yeah.
Yeah.
Going there, and then these are the meetings that you're looking at, like the Zooms.
I don't think the Thursdays have been posted yet, right?
No, later.
No. Yeah, because
Yeah,
we need to
they-
finish the meeting.
Do we know what the schedule is gonna be like for like the next couple of weeks? Cause it's gonna be kind of hard for me, since like I have work and stuff like that, to like know on a week by week basis. Since I get my schedule like 2 weeks in advance.
Oh, it doesn't stay the same. It changes the our
Yeah,
classes.
because next week we have a test.
Oh, okay.
Yeah.
That's gonna be a problem for me too then.
You guys might want to email the professor or your coaches to get more detailed information, because we actually don't have that information.
Yeah. We know it's going to be posted sometime Sunday or Monday to have you guys prepared. But that's as far as we know.
It's
Then
usually
we only get a weekend to like let our work know. Or, like 2 days.
Yeah.
sometime like before 5 though, right? I doubt anything will be past 5.
Maybe if they're still working on it, but yeah, it should be before 5.
Okay, all right. That should be.
Yeah, but we're good to go, guys. If you guys don't have any more questions, you're free to go.
Cool.
Thank you for participating.
Thank you.
Thank you.